Hi, today we are going to start our first lecture on pre-calculus by taking up the issue of translations of a graph. So let's see what this is all about. So here is a typical problem in this section. It says the graph of y equal to x squared is shown. Translate it to get the graph of here y equal to x squared minus 4, and another one is asking you to graph y is equal to quantity x minus 3 squared. Okay, I'm gonna describe this problem in general, and then I let you play with this problem so that you get the answers. Let's see. There are two ways to approach this problem. One is memorize about a dozen different rules for what you want to do to the graph of a function. Sometimes you want to move it to the left, right, up or down. You want to stretch it in one direction or another. You want to flip it, you want to rotate it, all sorts of things you want to do. And especially when you want to do them in particular sequence, the problem becomes rather tricky. So let's see. Suppose I have a function y is equal to x squared. Translations of the graph of y equal to x squared, the graph itself are straightforward enough. You've seen it many times. So here's a graph of y equal to x squared is a parabola. I'm going to leave that to you to get the details of the graph. So here is graph of y is equal to x squared. Imagine a wire bent in the shape of this red curve. Perhaps we want to move that wire to the right. Perhaps we want to move it to the left. Perhaps we want to go up. Perhaps we want to go down. The question is, what should I do to the equation so that the graph is going to do what I want to do to it? Well, simple one is if you take your variable, any of the variables you have, replace it by that variable minus some number, so x minus 3, and do as you were doing before, like you were squaring, you're still squaring. So what we did was replace x by x minus 3. What is that going to do? Probably have seen this problem once before, but let's go ahead and review. So one way to see what happens to the graph of this function is to track particular points of it. One special point in this graph is this tip of it, the tip of the parabola. Where is that tip in my new picture? Well, to get the lowest point, I need to set x equal to 3, and in that case I get y equal to 0. Any other value of x I choose, I'm going to get a positive answer. So here I say, to get the result, take your graph, move it 3 units to the right, and then just draw whatever you had before. Just take that picture and move it over 3 units. So this is graph of y is equal to x minus 3 squared. Another way of seeing what happened is to get the graph of this by a table. That is, for the original function, suppose we make a table. So the table is 0, 1, 2, 3, perhaps minus 1, minus 2, and so on. Y is the square of these quantities, so 4, 1, 0, 1, 4, 9, and so on. Now, if I have x, but what I do to it first is to subtract 3 from it and then square it. So if I have same 0, 1, 2, 3, say -1, -2, and so on, let's add some other numbers, say 4. When I subtract 3, when x is 3, I get 0, 1. Here I get -1, -2, -3, and so on, -4, -5. When I square these quantities, this 0 here corresponds to the 0 I had over here there. This 0 here corresponds to this 0 that I had over there. You notice that it is shifted 3 units to the right. Now 1 here, you square that, you get 1. This 1 corresponds to the one I had over there. So the second row that I had here is going to show up here as well, except it's just shifted 3 units to the right. So final statement that we make is that if you replace x by x minus 3 in any equation, the graph shifts right by 3 units. You might ask, well, what if I do y is equal to x plus 3 and then I square it? Well, if I add 3 to my x's, where would my tip of my parabola going to show up? The tip is going to show up 3 units earlier, because at x equal to -3 I get 0. So the graph is going to go to the left by 3 units. So the picture is going to look like this. So this is x, this is your y, -1, -2, -3, and my picture is going to be a parabola that goes up like that. So this is a graph of y is equal to x plus 3 squared. So to abbreviate, we say adding a 3 is equivalent to a shift left by 3 units. So we make a general rule: if I have some function, or if I have any equation, really, it doesn't have to be a function, if I replace x of it, so that's my original function, like y equal to x squared, and if I do x plus 3, this is going to be left by 3, and by that we mean shift to the left by 3. If I change my mind and subtract 3 from x, is going to be right by 3. It's again, we mean shift to the right by 3 units. Nothing special about the number 3. So if I say y is equal to f of x plus any number, we want to talk about the number, we call it a parameter. Sometimes we show it by some constant c. Now it all depends if your c is positive or negative. If c is positive, we are going to go right, we are going to go left by c. If c is negative, we are going to go right by, well, if c is a negative number, you might put it in absolute value to say we are going right by c units absolute value. Well, we did something to x and the picture moves accordingly. Notice that it's a bit counterintuitive perhaps to you. If I subtract, I go to the right. If I add, I go to the left. So it's opposite of what you might think. If I add, I go to the left. If I subtract, I go to the right. Well, what if I want to go up or down? So let's go back to our question here. What was it? The second question, if I want to subtract 3, that means I'm going to the right by 3. If I want to go up or down, how do I do it? Well, what variable represents height? the variable that represents height is y. So if I have, again, let's start from y equal to x squared. So y equal to x squared, our trusty parabola that we keep drawing it over and over again, x and y. Suppose I want to go up. Okay, I want to go up. First, let's imitate what we had before. You remember that we said if you want to go right, subtract from x. If I want to go up, I subtract from y. Y minus 4 is equal to x squared. So this is going to be exactly what we had before. Previously we had it for x's, now we have for y's. If I subtract from y, my graph is going to go up by 4 units. So this thing is going to go up here, goes up by 4 units. Now it so happens that we typically don't leave equation in that format. We write it in the so-called explicit fashion. So we write y, we take the 4 to the other side, becomes x squared plus 4. So sometimes they say if you want to move a graph up by a certain amount, add exactly that amount to the equation you already had. So here my equation that I had, if I add a 4 to it, this is going to be up by 4. This is the same as this thing, up by 4. This one has exactly the same format that we had. In this case, we said if you subtract, you go to the right. Here also I say if I subtract from y, I go up. Our tradition is to move our numbers to this side, and we are adding, and then we go up. Similarly, if you have y is equal to x squared minus 4, what do you think we are going to do? We are going to go down by 4. If you want to make sure you don't confuse with the rule that we had for the x, if you move the 4 to this side, becomes y plus 4 is equal to x squared. Just like the x, let me remind you, when we had the x, when we added to it, we went into the negative direction. Same thing happens here. When you add to y, you go in the negative direction. Negative direction of who? Negative direction of y. You're going to go down by 4, so it's going to be a graph that you had. You have to go down by 4 units. So that is the story of shifting to left or right, up or down. Sometimes you might want to do 2 shifts. What if I have y equal to x squared? I want to go up by 4 and right by 3. Up by 4, that means y minus 4 has to be x squared. Right by 3, it means that x, you have to subtract 3 from it before you square it. Now if you simplify this, you get y is equal to x minus 3 squared plus 4. So again, and there are 2 ways of handling this problem, treating x and y all the same. It's easier to memorize because there's the same rule that applies to both x and y. If you want to move everything to one side of equation, then for each particular movement that you have in mind, you have to have a particular rule memorized. So you choose which one you would like to do. Okay, next we want to go to next issue here, horizontal line test. Okay, what do we have in mind here? We have a graph of a function And the question is that is it one to one or not? Well, what is the issue of being one to one? What is significance of that? Suppose you are matching group A to a group B. Perhaps everyone from group A wants to dance with a person from group B, and everyone from group B wants to dance with somebody from group A. Well, can you always arrange such a dance? Obviously not if there's 5 in one group and 10 in the other group. So idea of one to one for a function is, can you match one x to one y and one y to one x, or is that different? So for example, here when you say you are dealing with a function, it means for each x you have one y anyway, so that's already taken care of. The question now is it true that for each y value you have only one x value? Suppose you have boys and girls in two groups. It might be that you can find a boy for each girl, but can you find a girl for each boy? So here we want to arrange the two groups so that exactly one person from this group matches against one person from the other group. So for example, here in graph 1, you see that if I choose any y value here, if I choose any y value, it matches to an x, particular x value. The only thing that might be in doubt here is the point down here. Which one is it that's going to be picked? You know that the empty circle means that is not in the picture, and filled in point means that that one is in the picture. So in this case, if my y value is 0, my x is just 1. There's no competition on the other side, so we don't have any issues with respect to matching of y and x. Same way here, if you choose any y value, for example, if my y value is 4, my x value perhaps somewhere between 2 and 4 is 3. If y is 6, then this is 4. If y is 8, this is maybe 5 or something. Any y value that I consider, like for example -6 here, seems to match almost to -5. Does it match to some, does each value of y that you have match to just 1x? This one also seems like that it is 1 to 1. How about here though? It is true that for each x we have one y, meaning if you draw a vertical line, you just cut it once. But what if you draw the horizontal line? If you draw a horizontal line, in this case, you see that you cut the graph twice most often. Well, right at the tip is just once, up here you don't cross at all, but down here you cross twice. What does that mean? It means there will be two different x values that match to one y value. How about here? Well, you continue this idea. So what is this topic called? It's called the horizontal line test. Horizontal line test is used to see if a function is 1 to 1 or not. If I draw a horizontal line, do I cut it only once? Well, here you see the situation is very extreme. You cut this function plenty of times when you draw a horizontal line. How about here? Well, if you draw a line, cut this in just once, but here you're cutting twice. Here you cut once, here you cut once. But the fact that there is one situation in which a horizontal line cuts the graph twice indicates that the function is not 1 to 1. Again, here this is not 1 to 1, this is not 1 to 1, because we have two instances where what we wish for is broken down. So what is the idea then? The idea is 1 to 1 if you have a graph of a function, you ask yourself, what does it how does it deal with horizontal line? If a horizontal line cuts it twice, here it cuts it twice, this function is not one-to-one. This function is not one-to-one. Well, why do we care if a function is one-to-one or not? Well, let's go back to that trusty parabola we just talked about in the first lecture. So say y equal to x squared. So of course, if I have a number here, say let's pick up a number 2, it corresponds to 1y. That makes it a function. Okay, that's a 4. But if I choose a particular output 9, if I choose a y, does it correspond to just 1x or no x or more than 1 x's? Well, draw your horizontal line to see what points have a height of 9. You notice that here's your issue, that you have both 3 and minus 3 points that match to 9. So we need to have a clear mind as to when we want to go back, which one of these two are we going to go back to. Where do you face that issue? You face that issue when you're taking square root. We say square root of a number, if it exists, is a non-negative number. This is not chosen, that one is chosen. Square root of 9 is 3. Your high school teacher might have said plus or minus 3, but in classes that you are going to have from now on, square root of a number, square root of a positive number is a positive answer. Square root of 0, well, that's just 0. Square root of negative number, well, that's going to be an imaginary number. We will talk about that perhaps later on. Okay, so that's a story of one-to-one. That's a simple story.